Weiroll is another side project that I've been working on with Dean Eigenman and Matthew DeFerenti. And the basic idea is that there are a bunch of solutions around for batching operations in order to turn multiple operations into a single atomic transaction. And so, for instance, there is Instadap, there is DeFi Saver, and there are a few other systems that are similar. At the very basic end of things, we have things like multi-call, which allow you to just batch multiple operations, but don't support data dependencies between them. Existing systems like this tend to have some significant weaknesses. Either they use oodles of gas because they rely on things like smart contract storage for passing data between operations, like Instadap does. Or they have limitations on their flexibility in that there's only certain ways you can pass stuff between things, like named slots and only a single return value. Or they have very complex architectures, like I believe DeFi Savers does, with multiple different types that have to be multiple different storage areas that have to be taken from, and so forth. So Weiroll is our attempt at building an extremely straightforward VM that can execute arbitrary chains of transactions and pass data between them in a transparent fashion. The basic idea is that the Weiroll VM has, and I really wish I had a diagram here, has when you call the VM, you pass in two things. You pass in an array of commands, and each command specifies a smart contract function to execute. And you pass in an array of state values, and each state value is a bytes, so it's arbitrary length, and it represents an argument or a return type for that command. So the command specifies the function selector, a flag that specifies what sort of call you're making, whether it's a delegate call or a regular call, and so forth. And then a series of input values which are taken from the state, and a single output state slot, and finally the address that you're calling. So what the VM does is it simply it assembles the input arguments from the list of state variables that were specified in, and then calls the target address with the function selector and the compiled data, and then writes the result to the output. And this is sufficient to have arbitrary chaining of functions with complex arguments and so forth. This is much simpler than existing solutions which rely on, say, having input values and output values and also return values from previous things, because we put everything in this single state array. So as an example, if you wanted to add two numbers, your command would be a call to the add two numbers function. Your state would be the two input numbers. And then your command word would say, this is the add function. The input arguments are the first state slot and the second state slot, where the two numbers to add are. And your output is either of those, say the first state slot to overwrite the result to. And in this way, you can even, for gas efficiency, reuse existing state slots in order to save on gas. This is very straightforward, but somewhat awkward to program for, because you have to plan slot allocations and so on and so forth. So we have written a planner in JavaScript called Weiroll.js. And the way this works is it provides a really easy way that you just create a series of smart contract calls in JavaScript, and it handles how to actually turn that into a Weiroll program. So we have some example code here. Starting here, you construct a new planner, and then for each function you want to execute, you take the contract object, which is basically like an Ethers contract, only wrapped in our own library, and you just call the function on it with the arguments just like you would a normal Web3 contract call. And you pass the result of that to planner.add, and it adds it to the list of commands. And then if that contract function has a return value, you can capture it just like you would anything else, and then pass it into another contract call later. And the planner will detect that you used this return value and where you used it, and then automatically make sure it allocates the state slots and the inputs correctly, so that all the data gets routed correctly. And then once you're done adding all of your function calls, you simply call planner.plan. I hope people can make this out. My text is probably a bit on the small side. And planner.plan returns the list of commands and the state, which you simply pass into the VM to execute. So the idea is that using this to chain a series of commands into a single transaction should be as easy as simply doing it as if you were doing it with ethers.js or web3.js. Only at the end, it generates the plan for you and you send only that in the actual transaction. And that is the high-level overview. We've written the whole thing. The overhead was, I believe, about 6k gas per command dispatch, which is on the high side, but still significantly better than all the competing solutions. We're currently in the midst of rewriting everything in YUL, and we've saved about 30% gas writing it in YUL as opposed to Solidity. And fortunately, because the VM is reasonably straightforward, that's actually a practical thing to do without it getting insanely complicated. So that'll bring it down to possibly as low as about 4,000 gas per dispatch, which is still higher than I would like, but significantly better than what anyone else has achieved, I believe. This also, incidentally, supports what we call subplans. So if you want to do flash loans, for instance, you can tell it, go off and call the flash loan function, and you can pass in the data necessary to instantiate a nested version of the Weiroll planner that then does stuff inside the flash loan. And this is all supported transparently so that you don't have to deal with all the plumbing of connecting the two instances together yourself. The planner JavaScript library just handles it for you. So that is the somewhat disorganized high-level overview of Weiroll. Any questions?
Thank you so much for the impromptu second presentation there, Nick. Really appreciate it. Are there any questions for Nick on either ENS and Layer 2 or Weiroll? Johnny, I'm not sure if that clears things up for you. I believe you can unmute yourself.
Oh, I can now. Hi, Nick.
Hi.
I have two small questions. One is, what's your favorite L2? And if you feel comfortable saying, and then also this Weiroll thing, how it's batching these commands together, what effect does that have on MEV as far as hiding what's going to be happening so people can't figure out what's going on in a transaction that's being executed?
Yep. So in terms of favorite L2, Optimism is by far the one I'm most familiar with because I dug way into its internals to construct a demo for Durin back before it was called Durin. And it seems well conceived and so on. So it's kind of a de facto favorite rather than like I've carefully examined every single one. We would love to work with them and like potentially others as well to build like general purpose gateways for Durin so that they can be used for ENS and for a bunch of other stuff as well. In terms of Weiroll batching, the MEV implications unfortunately aren't great because the more sophisticated general purpose front running bots don't just try front running the whole transaction from their account, they actually try front running individual contract calls. So depending on how you structure your Weiroll invocation, they might be able to just like play your entire transaction and make whatever MEV you were trying to extract with your Weiroll program. Or they might identify that they can like replay some subset of that and do that automatically. So unfortunately, their ability to simulate just about anything makes it very difficult to evade this.
Cool, great, thank you. Johnny has just a comment. Yeah, like your Weiroll explanation was super clear. Impressive ad hoc presentation. I'm impressed that you got it.
I'm glad. I'm particularly proud of the planner too. So if people want to dig into it and play with it, like I really like the fact that we've managed to completely separate the VM architecture, which is straightforward but unintuitive, from like a really obvious, like very similar to Ethers UX in the browser.
Cool. Yeah. Anyone else have any questions? And if not, then we can. Thank you, Nick. Thank you for popping by and presenting. It's in the afternoon right now for you in New Zealand, isn't it?
Just about, yeah. It's 20 past 12.
I thought it would have been like late at night for you. Johnny asks, is Weiroll live?
It's so the Solidity version works, but our testing is on the light end, so I wouldn't recommend deploying it to production. The Yule version is still in progress and doesn't pass all the tests for the Solidity version yet. We definitely need to spend more effort on unit tests and code coverage before we can like tell anybody that they would actually be well advised in giving it a go on a real network.
Great. And also, like, I just forgot as an additional comment to your last answer that there's your call to action for the developers. Go play and test with Weiroll and also ENS.
Yeah, please do.
Yeah, Nick, thank you for stopping by. I appreciate it. Appreciate your time.
Thank you.